Imagine a vast, frozen land where hidden secrets challenge our understanding of the world. Beneath Antarctica's thick ice sheets, scientists are using radio frequency technology to uncover ancient relics from a distant era. Yet, despite some fascinating discoveries, about 90% of this continent remains shrouded in mystery. What else could be hidden beneath all that ice? Antarctica might look like a vast white expanse on the map, but its size is staggering. It's the fifth largest continent, larger than both Europe and Australia. And there's more. During the winter, the surrounding ice expands, increasing Antarctica's total area and making it even more immense. To put its size into perspective, let's compare Antarctica to North America. While North America is densely populated and covered by diverse ecosystems, Antarctica rivals it in sheer scale. It spans an area equivalent to the contiguous United States and Canada combined. This enormity gives Antarctica immense significance for the planet, impacting global climate and even geopolitics, including territorial disputes. Despite its vastness, Antarctica is one of the most inhospitable places on Earth. Its immense size doesn't make it welcoming. Far from it. The extreme conditions keep any permanent population away, with human presence limited to temporary research stations operated by a handful of countries. During the Antarctic summer, when temperatures are less harsh and sunlight lasts nearly 24 hours a day, around 4,000 scientists and technicians occupy these stations, exploring the continent's unique climate, geology, and biology. As the harsh Antarctic winter sets in, this number drops drastically, with only about 1,000 people remaining. This sharp decline reflects the severity of the conditions, as winter temperatures often plummet below -34 degrees Celsius, with records as low as -80 degrees Celsius in the interior. Furthermore, the continent is cloaked in near-total darkness for months due to the Earth's tilt, making any attempt at sustained habitation nearly impossible. Despite these challenges, the presence of these scientists stands as a testament to human resilience and innovation. They work tirelessly to unravel Antarctica's mysteries, developing survival technologies and operating in facilities designed to withstand conditions that are nearly alien. Living in Antarctica means adapting to an environment that defies human habitation, yet holds critical answers for understanding our planet. The frozen continent is not only one of the most inhospitable places on Earth, it is also one of the most isolated. Antarctica, already a region where survival is a daunting challenge, is incredibly difficult to reach. Most expeditions to the continent must brave one of the planet's most feared sea crossings, the Drake Passage, located between the southern tip of South America and the Antarctic Peninsula. This strait is infamous for its treacherous waters, caused by the convergence of ocean currents from the Atlantic, Pacific, and Southern Oceans. These powerful currents, combined with relentless winds that sweep through the region, generate waves that can reach up to 20 meters in height, making the crossing a true endurance test for vessels. This is one of the main reasons access to the continent is restricted to certain times of the year and relies on highly specialized ships and aircraft. Those who manage to conquer the Drake Passage still face the formidable task of transporting and installing infrastructure in an environment where any mistake can have severe consequences. Antarctica's geography and isolation demand complex logistics and significant resources to ensure the safety and support of researchers who spend seasons there. It's a colossal effort, but one that makes temporary human presence and scientific exploration possible. The extreme isolation and difficult access make Antarctica a true enigma. Yet what happens there has direct repercussions for the entire planet. The continent is covered by an ice sheet that spans 98% of its surface, forming one of the world's largest freshwater reserves. It is estimated that this massive ice sheet holds about 61% of all freshwater on Earth, making its preservation crucial for global climate stability. This ice isn't just a frozen expanse, it serves as a barrier against rising sea levels. Studies suggest that if the entire Antarctic ice sheet were to melt, sea levels could rise by approximately 60 meters, flooding coastal regions and cities worldwide. Even a small change in the ice sheet's volume has significant consequences, altering ocean current circulation and impacting the global climate. Despite its remote location and extreme cold, Antarctica is not immune to global warming. Temperatures in certain areas, particularly on the Antarctic Peninsula, have shown slight increases. This warming trend is alarming scientists, as it could accelerate the melting of parts of the ice sheet, triggering a rise in sea levels far beyond current predictions. Beneath Antarctica's thick ice sheet, hidden from the world for millions of years, lies a fossilized and nearly untouched landscape. For decades, this vast subterranean world remained a mystery to science. However, advancements in radio frequency detection and ice-penetrating radar have allowed scientists to uncover a surprising past, one that reveals a continent vastly different from the frozen expanse we know today. Imagine a land filled with deep valleys, rivers, and even complex drainage systems, frozen in time yet still present beneath the ice. By using radio waves that penetrate the ice and bounce back upon hitting the rock and formations below, researchers have mapped large sections of this hidden terrain. This technology creates a kind of image of what lies beneath, much like an ultrasound for the continent. The findings suggest that millions of years ago, Antarctica was a lush, habitable region connected to other continents as part of the supercontinent Gondwana. During that time, Antarctica had rivers flowing through valleys, perhaps similar to today's great river systems. Some of these rivers have fossilized under the ice, forming preserved tunnels that provide insights into how water shaped the continent's subsurface during a dramatically different climate. These fossilized valleys offer crucial clues about Earth's past and how Antarctica's dynamics sculpted its topography over millions of years. Moreover, these discoveries challenge traditional notions about the continent. Some scientists propose that liquid water might still exist in isolated pockets beneath the ice, where high pressure prevents freezing. This phenomenon could resemble the subglacial lakes that might host resilient, highly adapted organisms capable of surviving in such extreme environments. With about 90% of the continent still unmapped beneath the ice, Antarctica resembles an alien world, holding secrets about climate and tectonic forces that shaped the planet. Among these valleys and fossilized layers, scientists have also found evidence of ancient ocean currents and possibly tectonic activity. These findings shed light on how Antarctica remained isolated from other continents for millennia. Understanding this hidden terrain is also critical for predicting Earth's future. As the ice sheet responds to global temperature changes, the dynamics of the underlying landscape help forecast glacier movements and the potential impact of large-scale melting. Such a process could have catastrophic consequences for sea levels and the global climate. Despite Antarctica being one of the most extreme environments on Earth, it is far from devoid of life or valuable resources. Quite the opposite. Beneath its vast ice sheet lies a hidden world with immense scientific potential and resources that could benefit humanity. Deep within the icy depths, scientists are uncovering signs of life in the most unlikely places, revealing organisms that not only survive in hostile conditions but thrive in them. These organisms, known as extremophiles, challenge the limits of terrestrial biology and open doors to research in health, biotechnology, and even space exploration. Life has been discovered in volcanic caves, such as those around Mount Erebus, where geothermal heat creates warm microenvironments. These caves harbor life adapted to extreme conditions, including a lack of light, freezing temperatures, and deep isolation. Samples taken from these caves have revealed DNA from algae and tiny animals, including previously unknown species. These life forms contain resilient substances and enzymes with potential biomedical applications. For example, enzymes adapted to extreme cold could be used to develop more robust treatments, such as new antibiotics to combat increasing bacterial resistance or to optimize industrial processes requiring cold environments. Deeper still, subglacial lakes such as Lake Vostok provide a glimpse into isolated ecosystems under immense pressure. These lakes, sealed off from the external environment for millions of years, mirror conditions found on frozen worlds like Europa, Jupiter's moon, and Enceladus, Saturn's moon. The study of these environments offers a unique opportunity to explore how life evolves in extreme isolation, potentially guiding future space missions and improving our understanding of where and how life could exist on other planets. Beneath Antarctica's ice lies not just life but also the possibility of valuable mineral resources, including iron, copper, coal, and rare minerals like cobalt and lithium, key elements for green technologies such as electric vehicle batteries and wind turbines. With the Antarctic Treaty up for review in 2048, which currently prohibits resource exploitation, debates have arisen about regulated and sustainable resource extraction. While mining activity raises serious environmental concerns, accessing these strategic minerals could boost global green economies, provided strict controls prevent irreparable harm to the Antarctic ecosystem. Antarctica is also believed to harbor potential reserves of oil and gas that could rival those of Saudi Arabia. If controlled exploration were permitted in the distant future, such reserves could help alleviate global energy crises and assist in transitioning to greener economies. However, this prospect must be approached with extreme caution, as any spills or environmental impacts could trigger catastrophic global consequences. Beyond biodiversity and minerals, Antarctica is crucial for global water security. The continent holds about 61% of the planet's freshwater in the form of ice. In a scenario of extreme scarcity, even a small fraction of this resource could be utilized, offering insights into water purity in its original state and techniques for conservation. Studying the ice layers also provides a unique window into Earth's climatic past. By analyzing air bubbles trapped in the ice, scientists can reconstruct atmospheric compositions from thousands of years ago, mapping cycles of warming and cooling to predict the impacts of current climate changes. Understanding Antarctica also requires knowledge of its geological structure. The continent is divided into two major regions, East Antarctica and West Antarctica. East Antarctica, which comprises most of the continent, is one of the oldest regions on Earth. Formed by stable tectonic plates and composed of rocks dating back billions of years, it holds fossils and minerals that reveal the planet's early history. This area is covered by some of the thickest ice layers on the continent, reaching thousands of meters deep and preserving a rich geological record of ancient times. Hidden beneath its surface are mountains and valleys, with ancient rocks holding clues to the formation of the first continents. On the other hand, West Antarctica, often referred to as Lesser Antarctica, is much younger and geologically active. Unlike the stability of East Antarctica, this region consists of multiple islands and areas shaped by tectonic and volcanic activity. Volcanic islands emerge from the ice in some areas, showcasing dramatic landscapes with craters and rock formations shaped by volcanic forces. A standout feature in West Antarctica is Mount Erebus, the southernmost active volcano on the planet. With its bubbling lava lake, Mount Erebus is a rare exception in the frozen continent. Its geothermal activity creates subterranean caves with relatively mild temperatures compared to the surface's extreme cold. These caves serve as refuges for microbial life specially adapted to extreme conditions. For scientists, this environment is a natural laboratory simulating life in similar conditions on distant frozen moons. These two regions, vastly different in age, structure, and geological activity, make Antarctica a dual continent. The ancient stability of East Antarctica contrasts with the dynamic activity of West Antarctica. Adding to this fascinating geology are the Gambart-Sev Mountains, one of the planet's most intriguing formations. Comparable to the Alps in height and size, this mountain range remains completely buried under about 600 meters of ice. Discovered in the 1950s, the Gambart-Sev Mountains were a surprising find in a continent largely characterized by flat, ice-covered terrain. With peaks reaching thousands of meters, this range stretches across a vast area, forming a landscape that was entirely unknown until recently. For scientists, the Gambart-Sev Mountains are another key piece in understanding Antarctica's history. They act as a natural archive, preserving evidence of the continent's early formation. Although inaccessible, This mountain range is being mapped using radar technologies that digitally reconstruct the structures beneath the ice. Antarctica's layered mysteries, from its ancient geology to its dynamic ecosystems, make it a cornerstone for scientific discovery and a critical player in understanding our planet's past, present, and future. Beyond its towering mountains, Antarctica is also home to over 400 subglacial lakes, with Lake Vostok being the most renowned and one of the largest. This massive lake, located nearly 4,000 meters below the ice surface, has been sealed off for at least 15 million years, creating an entirely isolated ecosystem. The discovery of Lake Vostok unveiled a unique environment with the potential for life forms that evolved independently, untouched by the outside world. For scientists, Lake Vostok offers a remarkable opportunity to study how life could adapt to extreme conditions of pressure, darkness, and cold. With the possibility of unknown microorganisms thriving in its depths, the lake becomes a natural laboratory, providing valuable clues about how life might exist in harsh environments, even beyond Earth. By now, you've probably realized that Antarctica is far more than just a frozen continent. It's a living archive of the past and a scientific frontier brimming with potential for exploration. Its depths hold secrets about the climate, the origins of life, and the limits of human survival, offering answers to some of Earth's greatest mysteries. Each discovery in this extreme environment reveals not only the power of nature, but also our responsibility to preserve it. Ethical and respectful exploration of Antarctica is essential to protecting one of the planet's last untouched frontiers, a place where the past, present, and future converge. The question remains, can we safeguard this legacy for future generations? If you enjoyed this mini documentary here on GFlow, don't miss the next one that's appearing on your screen right now. Thanks for watching, and see you there.